Welcome guys, I hope you are well, particularly my 9M4 class, but for anybody else listening in, welcome. This lesson is on constant and variable rates following my last lesson, which was on in an introduction to rates for Year 8 and Year 9 students. So I'm going to probably link in last lesson a little bit to start off with, and I'm going to be using this example, but I'm going to be writing it slightly different. So for my class, whack the heading down constant and variable rates, followed by this example. I want you to write this down, please. Write 270 kilometers in 3 hours as a rate, and hence sketch a time distance graph. Okay, so that's the question I want you to write down, and it is in front of us, but I'm going to show you how you transfer from that question to the answer. Now, to start off with, at any time, you may pause this, write things down, and then you can play it at your own pace. Okay, so yesterday, last lesson, we looked at writing the rate of 270 kilometers per 3 hours as a simplified rate. Now, hopefully you remember, as a simplified rate, this needs to be kilometers per 1 hour. So how do I get 1 hour if I've currently got 3? Well, we'd simply divide it by 3 to get 1. We divide this by 3 to get that simplified rate of 90 kilometers per hour, which means for every hour that I'm traveling, we reach 90 kilometers. So that's the first part of this question. And I do want you to write down, because this is quite important, because I'm traveling 90 kilometers for each hour, this is what we refer to as a constant speed brackets rate. All right, so how do we draw this into a time distance graph or a distance time graph? Last year you looked at linear algebra, where you drew up an x and a y axis, often using a table of values, and then you plotted coordinates, and then you might have discussed things about the gradient, etc. Now, for this question, you could draw up a time distance graph if you wish, remembering that that time, we always like to have time on the x-axis, okay, and this time is in hours, and we often like to have the distance on the y-axis. In this case, the distance is in kilometers. So it's called a distance time graph or a time distance graph. Now, you can put a table of values out, but to be honest, guys, I don't really like that. For this kind of question, you should be able to do it straight. Now, in my first hour, I'm going to put maybe 3 hours because that's what we started off with. We traveled 90 kilometers, and over the 3 hours, we traveled 270 kilometers. So what we might need to do is I'm going to go by 90, so 90, 180, because that's what I'm going for each hour, 270. So it makes it nice and easy to plot some coordinates. So in that first hour, we travel 90 kilometers. I'm going to put a dot there. In the second hour, we would travel, 2 times 90 is 180. But again, that can show that I'm only going up another 90 kilometers for that hour. In the third hour, from the question, it said that we went 270 kilometers. But again, 90 added on to 180 is 270. And what you'll notice that if you've drawn it accurately, those 3 dots will be perfectly aligned to go from the point of origin. And I'm simply going to draw a nice straight line with my ruler. Hopefully you're using a ruler. Okay, and you have a nice graph, and that's what they've got there as well. And you can clearly see I've got those coordinates there. That's the coordinate 190, the coordinate 2 180, and the coordinate 3 270. And so I've pretty much answered my question, but we're not going to stop there because I do want to talk about the gradient. Now, you may or may not have spoken about the gradient last year in your classes. I want you to write that word down underneath that graph because this is really important. We're going to be doing a little bit about the gradient, okay, just to relate to what we're doing with rates. Now, the gradient represents how steep or what the slope is like. So obviously, if you have a big gradient, the line is very steep. If you have a really small gradient, the line will not be very steep, which means we're not going particularly fast. Now, last year you may have looked at the formula, and I want you to write this down. To find the gradient, you would find the rise over the run. And that's often if we drew like a little triangle in to our actual diagram. As you can see there, I've got a little right angled triangle there. Now the rise is how far we go up. In other words, we go up 270 kilometers altogether across a run of 3 hours. And that makes sense because in 3 hours time, we traveled 270 kilometers. So if I put the rise 270 over the run of 3 hours, what is our answer? Well, hopefully you get 90 as your answer. Now, 90, I've seen that number before, haven't we? If we go back up to our rate, look at that. That rate is the same number. And that is because the gradient is exactly the same as the rate. And I want you to write that down. Same as the rate. Because what the gradient does, it describes how steep a line is going. And that's what the rate does. Think, if you're going at a rate of 90 kilometers per hour, that's your sort of the shape of your line. If I was going, let's say, 270 kilometers per hour, what would happen? You put the line up here, put your point at 270, and then look at your line. Oh, it's heaps steep. That's because you're going really, really fast. Please don't go 270 kilometers per hour because it's not probably safe. If you're going 90 kilometers in 3 hours, well, look what happens to the line. See how it's now not very steep? So there's lots of ways that we can look at this, but the concept for today is that a constant rate is the same as the gradient. Okay, and we find it the same way as doing the rise over the run. A lot of the time, though, you won't think of it as rise over run. You'll just do it naturally by looking at the graph. Okay, next question. Each diagram below illustrates the distance travelled by a car over time. Describe the journey, including the speed of the car. So what we're going to do, I'm going to put some letters here. So at the initial starting point, we are at point A, then we're at point B, at point C, and point D. I'm taking all particular points where things happen. For example, at point B, the line changes. At point C, the line changes. And it's going to allow me to talk about what's occurring. So, from A to B, what is happening? Well, hopefully you recognize it's a straight line. So it means that we're going at a constant rate or a constant speed. But it does say include the speed of the car. So, well, how fast am I going? Well, we're traveling a total of 80 kilometers over a period of 2 hours. Now, we could write it like a rate, like we've been doing, 80 kilometers in 2 hours, and then say, well, as a rate, that would be 40 kilometers per hour. But if I use the rise over the run, or the gradient, we're doing the rise is 80, the run is 2, and 80 divided by 2, that equals 40. And so you can do it the two different ways. But from A to B, I'm at a constant rate of 40 kilometers per hour. Now, at point B, what happens? There's something that's significant that happens from point B to point C. Well, hopefully you recognize that from point B to point C, I'm not actually going any distance at all, which means that I have stopped. But a better word for stopped would be stationary. It's a really good word that we often use in mathematics to say that we're not traveling anywhere. If you think about it as the gradient, there's no rise, is there? Which means the rise is 0, which means you're stopped. There is no gradient, therefore you are stationary. And then what happens from C to D? Well, from C to D, what's going on? Well, we're going at a constant speed again. Let's have a look at how far we go. We go 40 kilometers over 1 hour. So 40 divided by 1, well, that's just 40 kilometers per hour, isn't it? So we're traveling again at a speed of 40 kilometers per hour. So we could say that would be, for me, I'm happy for you to have that kind of working out. If you want to make a sentence, you could say from point A to point B, we travel 40 kilometers per hour, and then I stop for an hour, and at point C, I start off again at a speed of 40 kilometers per hour. If I look at B, and again, it's a good idea for you to stop this video, pause it, have a go at the question, see what you can come up with. Okay, so I'm going to put point A. It changes direction there, or speed, not direction, speed, and then C there. So let's see what happens. So from A to B, all right, we're going at a constant rate of, we go 80 kilometers over 2 hours. So using the gradient, the rise is 80, the run is 2, which means once again we're traveling at a speed of 40 kilometers per hour. And then from B to C, what happens then? Well, we slow down, don't we? So let's see how far we go. Now, it's not particularly clear, but it looks like that's about 100. And that looks like it's 100. So if I look at that distance there, from 80 to 100, it means we've gone 20 kilometers over a period of 2 hours. So 20 over 2 equals 10 kilometers per hour, which means that we've actually slowed down a little bit. Now, in terms of the gradient, this is a little bit of extension, but I'm just going to mention it. In terms of the gradient, we've just gone through the formula of the rise over the run. And for most questions, you'll be able to see what the rise of that triangle is going to be. But that one's a little bit more challenging. And so what's the more fancied formula? And certainly 9 Maths 1, 10 Maths 1 will be doing this formula. They say y2 minus y1 over x2 minus x1. And what that means is, to find out what the distance of the rise is, they look at the difference between the two y coordinates. We mentioned that was 100, and we'd say that's 100 take away 80, and then let's see what the x value is 4, and the x value there is 2. So 4 take away 2, and if you put that into your calculator, you're going to come up with the answer of 10 yet again. You might see it around. We probably won't use that at this time, guys. We'll just be using that rise over the run. But a lot of the time, you're probably just using a bit of your common sense there as well. All right. Draw a time distance graph to illustrate the following journey. So we're drawing a time distance graph. We've already drawn one in that very first example. I'm going to put here time, and we're going to be looking at this in hours. And this is our distance, and we're in hours. Okay, so how far are we traveling? Well, we're going, a cyclist travels for 1 hour at a constant speed of 10 kilometers per hour. So he's traveling 10 kilometers, and then stops for a 30-minute break before riding a further 6 kilometers for half an hour. Well, I'm going to go by half hours. So 0.5, 1 hour, 1.5, 2 hours. And 2.5. Now we need to be traveling an hour at 10 kilometers per hour, and then a further 6. That means we're going to be going a total of 16 kilometers. So I'm going to go by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18. And again, I'm going to label that nice and clearly. And in your books, guys, you should be doing this, but you should be using a ruler, please, to make sure you are very, very accurate. So that's my x and y axes, or my distance and my time axes. I'm now going to plot some points. So in the first hour, we travel a total of 10 kilometers. So I'm going to go put up a dot there. Now, it then stops for 30 minutes. So he stops for 30 minutes, which is there. I'm going to start drawing my graph because there's a sort of change. That's where my change occurs. And then what happens after that? After that, he travels a further 6 kilometers for half an hour. Well, that goes to 2. So I'm going to go from this point another 6 kilometers. So I'm going up to 16, put my dot there, and I'm going to draw my line. Perfect. And there you go. That's as hard as it gets. Okay, again, if you're wanting to look at the speed, you could work out the speed for the last one, because if you wanted to look at it, that's your rise and your run, which means you're traveling 6 kilometers in just half an hour. So if I do 6 divided by a half, we're going to get 12 kilometers per hour. Look at that, hey? And you can see that line is slightly steeper than the first one, because that was 10 kilometers per hour, and that one is now going to be 12 kilometers, so it's just a little bit steeper. Okay, now that's pretty much the lesson done, guys. The last thing I want you to look at, I am mindful it's nearly 15 minutes, is just the difference between a constant rate and a variable rate. I'm going to put here, I want you to write this down, A constant rate is a straight line. That is, the rate does not change. And underline the not. And now I want you to put a variable rate as a curved line, i.e., the rate is not constant, which means it changes. And all I mean by that, see for example here, that at every point in time, we're getting a little bit faster, 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 and then we start slowing down, and then we start slowing down, slowing down, slowing down, slowing down, slowing down. Okay, so it's a curved line, which means that the rate is not exactly the same at every single point in time. You'll get questions like this, where it'll ask you to describe what happens over the period of time. So for example, from start to point A, we're increasing at a slower rate, and all of a sudden we get really, really fast up until point B, where you're probably going the fastest you're going. And from point B, you're then starting to slow down. You're starting to slow down until you get to point D, and see how point D pretty much gets to zero, like a flat straight line, which means he's then stationary before he starts to increase his speed again. So you might be asked questions about this. I'm not particularly too concerned about the those variable graphs, but more about the constant stuff. Now, mindful again, guys, I've gone over 16 minutes. That's a big hit out for you. Please do the work that I've set for you via Sector Learn, and then or the teacher that you got today. Have an awesome day, guys, and I'll hopefully I'll see you next term.